For assignment 3, it is given draw the phase portrait as well as phase trajectory for van der Pol equation, and the corresponding equation has been described below. Now, this assignment 3 is combination of assignment 1 and assignment 2, and we are going to observe the existence of limit cycle particularly for this case. Moving to the next slide. For this assignment 3, we are going to use G input, and if I write help G input in MATLAB window, it says it is a graphical input from mouse. That means so far I was giving input while I am writing input first bracket and the corresponding string. But if I give G input, from the mouse click, the coordinate will be chosen. Please do remember the most important one, that G input gathers an unlimited number of points until the return key is pressed. So it is very important to remember. We will see that when we are going to solve the assignment 3. So moving to the next slide, there are additional common syntax we are using in the script. One is CLF. So if you remember, already we used CLC clear all. This time we are going to utilize CLF, which says that clear current figure and deletes all children of the current figure with visible handles. And there are one more command we are going to use, that help GCA, which says that it gets the handle to the current axis. So for the van der Pol equation, first step is to define the state variables. So what we have assumed, that first state variable x1 is y and the second state variable is y dot, so that I can write the equation x1 dot equal to x2, x2 dot equal to mu 1 minus x1 square into x2 minus x1. Next, what we have done, we have tried to write the program straightforward. You can see I have written clear all CLF here, and mu value has been assigned to 1. I will request you to try out when you can feed the mu as one of the input from the MATLAB command window, or assigning the value of mu from 1 to 1000, whatever you choose. Next, as we are talking about the phase portrait, we wanted to draw the vector fields, and for that reason what we have done is used the mesh grid command, where from -5 to 5 the range has been selected. If you ask me why I have chosen this range, it is based on trial and error method, that where I wanted to show you the best graph, and that way I have chosen. There is no as such suggestion. Once I have executed the program, seen the output and done the necessary changes. Next, I have written the corresponding x1 dot and x2 dot equation. So using the quiver command is utilizing the syntax whatever we have learned, but we have utilized this equation of a circle and plotted the vector field with respect to x1, x2 and these two variables, and we will see what will happen if I write this command. Those who are interested having the MATLAB or Octave can try out this command also to check what is the difference between the two. And as you can see, I have used the GCA command here itself. Next, instead of writing another subroutine in the same program, we have defined that function, and I have interfaced the graphical input, and very simple way already learned OD45 we have used, and we wanted to see what will happen if I plot this x1 and x2, basically nothing but the phase plot. So whatever I have discussed, the same thing is written in the script. What I am going to do is to execute the program and to see what is happening next. Trust me, you will be surprised what is happening in this program. So first, it has generated the vector field using the meshed grid. Now, as my G input is active, you can see the cursor is now active. Now I wanted to choose any arbitrary initial point to see the plot, and here it is. Now choose another arbitrary point again. So third one, fourth one, inside. So I hope you found its most interesting one to observe this limit cycle for the vendor Pol equation. Now already as the cursor is on, according to the common syntax, I can come out from this only if I give a enter here, and now the plot has been executed. So this is the solution for assignment 3, and I can see we have plotted the vector field as well as the phase plot for the vendor Pol equation. That's all for the assignment 3.